Okay. Hi, everybody. Welcome to our talk on CodeDeploy. My name is Andy Troutman. I'm the software dev manager for deployment systems at Amazon. So I own two sets of services. I own AWS CodeDeploy, which is our public-facing deployment system. I also own all of our services that we use internal to Amazon to do deployments to our infrastructure. Those systems are called Apollo. If you're interested in the differences and similarities between those two, my talk at last year's reInvent was all about comparing and contrasting our two different deployment services. You can find it on YouTube. With me today is Josh McFarland. Josh is my senior engineer on the CodeDeploy side. He also plays a big role on our internal deployment stuff as well. Before I get too deeply into this talk, I wanted to talk about a little piece of Amazon's culture that will be pertinent to this talk, and that is our pet culture. So some of you may be aware at Amazon you can bring your pets to work. Specifically, you can bring dogs to work. Some of the dogs in these slides are the ones that Josh and I work with, so these are deployment dogs. One thing that you'll notice about all these dogs is that they're various degrees of well-dressed. Some of them come to work naked. Some of them look like they're dressed for a Mardi Gras parade. One of them is wearing Seattle Casual, which is just any piece of flannel you can find and throw on. We really love working with our dogs, and it got Josh and I thinking about a business opportunity for our dogs. So it's a bit with a heavy heart that I have to say that this is going to be our last talk about CodeDeploy. Josh and I are going to strike out. We're going to found our own company with the vision of taking your dogs from something like this to something like this, right? I think you all see where I'm going with this. We're talking about custom, bespoke suits for your pets. So we put together a business plan. We started to get the idea off the ground. Josh started working on our custom fitting algorithms for dogs. I started to drum up support. We, did the rounds of VC funding, all that. And we also chose to build our application using CodeDeploy. So I'll focus this talk on how we went from humble idea to massively successful bespoke dog company. Why did we choose CodeDeploy? Not just because Josh and I have worked on it for many years and we have a lot of faith in it, but some of the early design tenets that we put into the service when we were originally building it really rang true for us as we kind of decided to strike out and start our own business and encounter all of the new discoveries of trying to get an idea off the ground. First of all, we built CodeDeploy from the ground up to be a building block service. By that we mean it should thunk into an existing process easily. Developers today have tons of tools at their disposal. All developers are likely already using a set of tools, and they run the spectrum from loving them to absolutely hating them. But most people would agree that they're not going to drop every single tool they have in their tool belt to adopt a whole new set of tooling. So we wanted to make sure that for CodeDeploy, we wanted to make sure that customers could pick up and use the service. They could drop it into their existing process. It wasn't intrusive. It felt natural, and it felt like an extension of what you were already trying to do. Another big aspect of CodeDeploy that we liked is that we had an early tenet of it being available everywhere. So as we take our dog suit business global, as we expand to Europe and Asia, et cetera, we know that the infrastructure services that AWS offers are available all over the place. We have many discrete regions that you can operate your services in, but our tooling has to follow that same principle, right? We don't want to adopt a set of tooling in one region and have it not carry forward to the next and the next. Today, CodeDeploy is in 5 AWS regions. We're aggressively expanding it to get it to all AWS regions, with the goal of it being everywhere that customers are. In addition to it being available in a lot of different AWS regions, we also want it to be available to do a lot of different things. So, for example, you can use CodeDeploy on Linux instances or Windows instances. You could deploy to EC2. You can also use CodeDeploy to deploy on premises. So if you're running your own data center, as long as you can get our agent installed on a piece of computing capacity, we can deploy to it. You can also deploy to your laptops or anything you really want. So we really love this. We don't know where our bespoke dog suit business is going to take us, but we suspect it's going to need to run on a lot of different platforms. Mobile app is an obvious next step. So we want to make sure that CodeDeploy is going to be in all the places we need to go. The final thing is scale. So after years of working on CodeDeploy, it was an early design tenet. We needed to make sure that CodeDeploy was easy to get started with when you're deploying to one instance, but it would scale up to allow you to deploy to thousands of instances. And again, a lot of the work we put into it, we're reasonably confident that CodeDeploy is going to meet all of our needs in that regard. So that's where those are some of the reasons why we decided to start this venture and use CodeDeploy to automate the process of application deployments. Let's go through like a really high-level overview of how CodeDeploy works. So in this example, there's going to be 3 players. There's going to be Amazon S3. Amazon S3 is where we're going to store the version of our application to deploy. CodeDeploy, which is the thing that's going to install or update our various pieces of code. And Amazon EC2, which is the infrastructure that we're going to deploy onto. First thing we'll do is we'll spin up some EC2 instances, which are represented by these lovely orange blocks. Once we have the instances up, we'll install on each one of them a CodeDeploy agent. CodeDeploy is an agent-based system. We basically run a piece of software on your instance, which constantly long polls the CodeDeploy service looking for work to do. So essentially, your instances are always connected, waiting for you to initiate a deployment or a request to make an update. When an update is issued, the first thing CodeDeploy is going to do is it's going to pick an instance or a set of instances to deploy to. In this case, let's just assume it's going to deploy to a single one. So it's going to send down a piece of configuration that we call an app spec file. I'll talk in more detail about what an app spec is, but for now, assume it's a piece of configuration that specifies how a deployment should happen on any particular instance we're deploying to. It's essentially a set of instructions for what should happen when an instance is selected for deployment. First thing that usually happens in an app spec file is that we're going to go download the latest version of your application. So in this case, we're going to go pull your application from S3. We could also pull your application from GitHub. CodeDeploy supports GitHub as well as S3 today. We're always looking for what the next set of software repositories people want is. And we're looking to kind of expand as we go so that you can kind of host your content wherever you want and still use CodeDeploy. Once the application is pulled down to the instance and unpacked and verified that everything looks the same as it did when we were storing it in S3, we're then going to run through a set of instructions that you as a developer or deployer specify. This is, again, specified in that app spec file. Essentially, we're going to run through a set of commands in the order you tell us to, and in that way, perform a software deployment. So the definition of how your software is actually deployed with CodeDeploy is really up to you as a deployer, right? Again, CodeDeploy, because we have this tenet about being flexible and easy to integrate in your process, we wanted it to be very application agnostic. We didn't want to make a deployment system that was just really great at deploying Java code. We wanted it to be able to deploy any code you want. We find that it pairs really well with existing configuration management tools. So if you're already configuring your instances with something like Puppet or Chef, you can use CodeDeploy to just invoke those same scripts that you're already using and use us to perform the rollout across the instances. Or you can write your own shell scripts, really whatever you want. Assuming that we run through all of these instructions that you give us and they all execute as expected, we'll assume that the deployment is successful, so we'll have a new version of the application running on this instance. CodeDeploy is going to see that this instance was successful, and it's going to pick another one, go through that whole lifecycle again, download your application bundle to the instance, perform your install steps, install the new application, again, etc., until we've deployed to all of the instances in the fleet. So at like a 10,000-foot view, this is how CodeDeploy works. It's essentially listening for deployment requests from you and then selecting instances to perform updates on. Let's talk about some of the modeling concepts that you're going to encounter when you perform your first CodeDeploy deployment. So there's 4 concepts that you're going to run into when you go to set up and use CodeDeploy. The highest level one is an application. An application is any collection of content that you want to deploy as a single unit. It's a somewhat abstract concept, so I used Einstein, noted for his ability to deal with abstract concepts. Let's look at an example to kind of motivate it. So an application could be a web server, so it could be Apache or Nginx or any other content-serving platform you wanted. Likewise, an application could be a custom framework, it could be a service framework, it could be a website framework, it could be Ruby on Rails or Django, whatever you wanted it to be. Both of these can be separate applications. You can model them completely independently. You can still deploy them to the same capacity. So if you want, you can deploy as many applications as you choose to the same set of EC2 instances. A third example might be just some content. So this could be custom business logic. For us, it's our proprietary dogfit algorithms, which are very hush-hush. Anything you really want it to be. It could be JavaScript, static assets, whatever. All of these could be separate applications, as I mentioned, or we could bundle them all into a single application. So again, we want to emphasize flexibility. We know people take different approaches to the way they release software. And CodeDeploy is not very committal about this. So if you're running a microservices architecture and you want lots and lots of discrete components that you want to update independently, you can model each of those as an application, and you can deploy them all to the same target capacity. Or if you want everything as a single versioned bundle that you can track more closely, again, CodeDeploy isn't too concerned about how you want to organize this. Once we have an application defined, so that's the thing we want to deploy, we need to define a deployment group, which is where we want to deploy it to. A deployment group is a collection of instances you want to deploy to as a group. This is a relatively simple concept, so I use Feynman, who's good at explaining simple things. The definition practically uses the, the name of the thing in it. So let's look at what a deployment group is. Here at Bespoke, Dogsuit Central, and at Amazon, and probably in many of the places you develop in, you'll commonly see a three-tier or three-stack architecture. This is a common development best practice. Have multiple stacks that you're running the code through, and for any piece of candidate change, you're transitioning it through those different sections. So on the left-hand side here, I have the dev stack. The developer stack is typically the newest version of your code. It's the one that's currently being developed. It's in the greatest state of flux. It's the least stable. If there is testing, it's minimal. You're usually writing testing along with the code. This is an opportunity for developers to experiment, to figure out how the logic or the business logic should work, et cetera, et cetera. Typically, this is not exposed to customers. This is really an internal-facing stack. Once you've identified a set of changes that look good, so a candidate set of things that you would potentially want to expose to your actual customers, your end users, the next step is usually a test stack. So a test stack is where you're going to actually prove that the business logic or proof out that the business logic that you've implemented works the way you want it to, right? So unit testing, integration testing, you might do performance testing here as well to make sure that resource consumption is in line with your expectation. You basically are using your test stack to build confidence that when you expose this change to end users, to your actual customers, that it works the way you expected it to. On the right-hand side, the further side over, is production. Production is the thing that your actual customers are using, looking at, and interacting with. It's, by definition, the oldest version of your code. It's also, in theory, the most stable version of your code because you've had a lot of different stages that you've tested it through at this point. So each of these can be modeled as a deployment group. You can deploy between them in any way you choose. Again, you can also have as many deployment groups as you like. It's not just 3 if you want very long chains of stages that you want to transition your code through. Again, CodeDeploy is very non-committal, as many deployment groups as you like, and you can define the transitions between them. So we have now an application that we want to deploy, some capacity that we want to put it on. Let's return back to that app spec file that I mentioned earlier. So this app spec file is a piece of YAML. It's just a piece of configuration that we recommend that you just check in along with your application. And it's used to define how the application is actually deployed. There's 2 sections of the app spec file which are interesting to talk about. The first is the files section. In the files section, we're essentially just having a map from that application repository, so S3 or GitHub, onto the file system, right? So in this example, I'm copying a config file to the web apps config directory, and I'm copying our services folder to web apps dogsuit. You can, again, move files anywhere onto the file system that you choose. This is just a simple set of copy commands, essentially. You can have as many or as few of them as you like. Once the file section is complete, there's the hooks. The hooks are those set of instructions that actually define how a deployment is executed or accomplished on your capacity. We have a bunch of logical groupings that we call lifecycle events. I'll go through the lifecycle events really quickly, just so you can get a flavor for how we sort of intended people to use them. The first event that happens is a start event that's just executed by the central service and basically tells the instance, hey, get ready, you're about to deploy. Then we kick it over to application stop. Application stop is an opportunity to run any scripts that you would use to turn off the old version of your application. So let's assume that we're deploying our dogsuit application from version 1 to version 2. This would be an opportunity to turn off version 1, disable it, get the instance ready to receive a new version. After the application stop events, download bundle happens. This is when we actually perform that pull command. So this is when we pull the new version of your application onto the instance. We do checksumming to make sure that it looks the same as it did when it was stored in S3. If everything looks good, we move on to the before install event. Before install is before we actually start copying files onto the file system in the places you specified in that file section. Typically, what we see people do in the before install event is they'll stash any logs or any configuration or data that they had stored as part of their previous install that they want to keep, right? So you can go grab up all of that content, stash it somewhere before you overwrite it with a new set of copy commands. After before install comes install. This is when we execute the file section of your app spec. This is when we're going to move everything to the places you tell us to. After install comes after install. We thought long and hard about that one. Typically, what we see people use after install for is if you've sent down secrets or encrypted data as part of that application bundle, now's an opportunity to decrypt it and put it where it belongs before we start up your new version of your application. So this could be things like database connectivity strings, passwords, account information, whatever it is that's sensitive that you wouldn't want to store in your app bundle kind of decrypted. After install is application start. This is turning on the new version of the application. So for us, turning on Dogsuit 2.0 instead of 1.0. You'll notice here that there's an optional parameter, which is a timeout. You can specify timeouts for any of the scripts that we run. If a script exceeds its timeout value, we essentially assume that that is a failure. That's not what you wanted to have happen. We'll mark that script as a failure, and subsequently we'll mark the deployment to that instance as a failure, and then the centralized service will make a decision. Right? So if enough instances fail, we'll stop the deployment. I'll talk about next how you can actually make it somewhat tolerant of a little bit of failure. After application start, so after we start up the new version of the application, there's one final hook that we expose, which is validate service. This is an opportunity to include any kind of validation logic you want to verify that the deployment went as expected, right? So this could be something very simple, like checking for a PID file. It could be something more involved, like calling out to a centralized testing services and have it hammer the box and make sure that it's behaving as expected. Once we run through all the steps, all the lifecycle events and all your scripts, if we assume that all of them execute as expected, the last thing is an end event. That's essentially when we record that this instance deployed to successfully, and we send that back to the central service, which will make a decision about what to do next. Either continue the deployment, or if a bunch of nodes have already failed, stop the deployment and let a customer decide to roll back or roll forward with a new version. Excuse me. So we have an application which we're going to deploy. We've defined some instances that we're going to deploy to. We've created some configuration which says how to perform the deployment. The last thing we want to specify is deployment config. Deployment config is how aggressively we roll across your entire fleet of instances when you tell us to deploy. So you remember in that first example I showed you, I was doing an instance at a time. So I was selecting one instance, updating it, going to the next, going to the next, going to the next. This is the slowest form of a deployment. It's also the most cautious form of deployment. So basically, if any instance along that chain fails, we'll immediately stop the deployment and let you decide what you want to have happen next. For most customers, if you're running a very large fleet, this is probably not how you want to deploy. If you're deploying to hundreds or thousands of instances, this would be a very slow way to deploy. So you'd really want to strap in and wait a long time. It also means that the deployment is somewhat brittle from the perspective of a large instance footprint. Many things can go wrong when a deployment is going out. You can have network connectivity issues to instances. You can have hardware failures. You can have applications that are in a bad state that makes the instance unresponsive. You want to be somewhat tolerant to single node failures when you're deploying to a very large fleet. And so for that, you probably want a different type of deployment config. The other two default deployment configs we offer is half at a time. That's what it sounds like. We'll deploy to 50% of your instances. If everything goes well with those, we'll do the next 50%. Most people, most teams in production will run their application over provision. So you'll run more instances than you actually need to serve your traffic so that any events don't impact your customers, right? So if you have a network partitioning event and instances are lost, you still should have enough instances to be able to serve traffic. If you make a bad software change, you should have extra instances. If you just have a spike in request load, like Dogsuit will have when it launches, you want to be able to weather that storm. We can take advantage of that over-provisioning during a deployment, and we can deploy to that extra capacity as part of the change. The third default config that we offer is all at once. That's what it sounds like. Put on your cowboy hat, go crazy, deploy to all of your instances in parallel as quickly as you possibly can. We don't recommend this for production. I asked Josh to not use all at once when he deploys Dogsuit app. But where it is very valuable is in your dev and test stack. So in dev and test, you usually are not exposing them to customers. The consequence of failure in this stack is relatively low. If I push a bad change, it's only slowing myself down or maybe the other devs on my team that I'm working on. The value of a fast deployment is probably greater than the mistake of deploying something broken, right? So you want to be able to iterate quickly, so push changes out as quickly as possible. If none of these work for you, you can always customize your own deployment config. You can specify a % of healthy hosts that you have to have available, or a raw number of hosts. And in this example, we're saying a minimum healthy hosts of 75%. So that means 3/4 of my instances need to be available at all times to serve my customers. So that means CodeDeploy can, in theory, take out up to 25% or 1/4 of your instances at any given time. So those are deployment configs. You've now graduated CodeDeploy Bootcamp. Congratulations. That's about everything you need to know to be able to use the service. Let's return back to the matter at hand, which is custom fashion for dogs. Let's talk about development. So Josh has been working on the fitting algorithms. We have a candidate in place. As you can see, the fit isn't particularly good for this dog, but it's time to start setting up a dev stack. In development, we're typically going to run a very small footprint. We might run it on a single instance. The focus of using CodeDeploy in our development environment is that we can get it integrated quickly and it doesn't get in the way. At this point, we don't have our VC funding come through just yet, and so we're spending our own money. We don't want Josh to waste a week of time trying to get automated deployment set up. If it isn't something we can kind of integrate quickly, it's not going to be worth our time. So let's switch and take a look at what it took to integrate CodeDeploy into our dog suit app. So we're looking at GitHub here. This is the commit that we made to integrate CodeDeploy into the environment. The first thing that you see here is that app spec file that I talked about earlier. The app spec file is less than 20 lines of code. I think it weighs in at about 17 lines of code. And this is that set of instructions that says how to deploy. In the file section, we're moving a WAR file into place, and we're copying a piece of port config to open up our development environment to traffic. So I should say that we developed this first version in Tomcat, so that's the technology we were used to. It was easy to get up and running. But we could have really used anything as far as CodeDeploy was concerned. The next section is the hook section. The hook section, we just have 3 hooks, 3 scripts that we're executing. An uninstall hook that will turn off the old version of Apache, a hook to install any dependencies we may have introduced as part of this new version of the application, and then a hook to start up the application. If Josh scrolls down, you can see the other things we've committed in here are the actual scripts that we're going to execute as part of this change. I'm not going to go into all the details, but they're essentially just shell scripts. They're probably things that a developer is going to write anyways, because you're going to get really tired of typing the same set of 5 or 10 commands to turn off Apache and move some files and start it back up. So we're really just taking things that you probably already wrote, and we're saying CodeDeploy, call them in this order for me. So that's what it looks like there. We'll go over to Jenkins. So we were already using Jenkins as a continuous build server. So we were already, anytime we checked in code, it would automatically get built. We want to just extend that. We want to now just kick off a deployment after a Jenkins build successfully completes. CodeDeploy made this relatively easy. They included a plugin for us. If you're using Jenkins and you want to integrate it with CodeDeploy, you can go to the public Jenkins repositories, and you should be able to hopefully get in. So once Josh fixes his login issue, we'll show you Jenkins. Sorry about that. So this is looking at the plugin. If you scroll down to the plugin, you should see the pertinent config that matters to us. It's essentially the same set of concepts that we already talked about. We need to tell the Jenkins plugin the application name that we're deploying, the deployment group that we want to deploy to, where we're storing the code. In this case, it's an S3 bucket, and what region we're deploying from. It's a relatively small amount of config. Once we set it up, we should be able to kick off a build and hopefully see a deployment happen. So we'll do so. There we go. So once we schedule a build, we can see it pop up here. We can go look at the console output. If you wanted to, you could sit in the Jenkins console and watch the build happen. Maybe. There we go. So you could watch the build happen. You could watch the Jenkins plugin automatically upload it to S3 and kick off a deployment. Once we see a deployment started, we're actually going to go to the CodeDeploy console just so we can show you some more things there, how it looks. So you can see we've got a new build started. If we click on that build, it'll take us down to an instance view. So calling out a few things that we talked about earlier. We're deploying our bespoke dog suit application. This is the dev deployment group. We're deploying to a single instance, which you can see down there below. And we're using one of those default deployment configs of all at once. This deployment finished pretty quickly. Let's click on View Events so you can show you what that looks like. So you can continue to drill down. You can start at a very high level, look at the instances we're deploying to. We can go all the way down to the lifecycle events that we're running on each instance if we want to. As you can see here, all of them succeeded. You can see when we started that lifecycle event, when it completed, how long it took, et cetera. So this deployment appears to have been successful. We ran through all our events as we wanted to. Let's go over to the beta website and see if it's up and running. So Josh will give it a quick refresh. There we go. So a moment to pause and reflect on where you were when you first saw Bespoke Dog Suit app. You were here at reInvent. So now that we have beta up and running, let's talk about what happens next. So as you can see, the fitting algorithm is starting to come into place. Our dogs are not looking so disheveled. We're talking now about getting a candidate release out, right? So we want to set up a test stack. What's going to be different about tests for us? First thing we're going to do is we're going to integrate with autoscaling. So when I talked about deployment groups, I forgot to mention how you actually define one. You can do it in one of two ways. You can tag a bunch of instances with a particular set of tags, and then you tell CodeDeploy, deploy to this set of tags. We'll deploy to those instances. You can also just give us an autoscaling group name, and we'll treat that as a deployment group. If you use autoscaling, you get a little bit of extra functionality, which is nice. Anytime autoscaling spins up a new instance, it won't put it into service until it's successfully received a CodeDeploy deployment, right? So in this way, you can guarantee that any new capacity before it goes into production and is exposed to your customers has a successful deployment of the latest version of your code deployed to it. We like this. We like this for our test environment, mostly because it turns out that Josh occasionally sleeps, and when Josh is sleeping, he's not coding. And so what we want to do is we want to turn off those test stacks when we're not using. Integrating CodeDeploy and autoscaling makes this easy. We just set our desired instances to 0. It throws away the capacity. Josh can take a quick nap. When he comes back in the morning, we dial it back up, and it automatically deploys the latest version of our code, and we're back up and running. Again, the VC funding has not yet happened for Dog Suit app, so we want to pinch pennies where we can. This was a great way to do that. The other thing we're going to introduce is request routing with ELB. Because we don't want to expose customers to an instance when it's being deployed to, we'll instead route traffic away from that instance while it's being deployed to. So in this example, we have Elastic Load Balancer on the left-hand side, an instance that we're going to update in the middle, and CodeDeploy on the right. What we'll do is, the first thing we'll do in the deployment is we'll route traffic away from the instance so that customers aren't hitting an instance as it's getting updated. Then we'll perform the software update, and then we'll reintroduce traffic to that instance. If we had to do this ourselves, we'd have to do a bunch of scripting to talk to the load balancer and listen for health checks and et cetera, et cetera, et cetera. The CodeDeploy team made this easy on us. They host a bunch of open source code in GitHub. So if you go to AWS Labs section of GitHub and you search for CodeDeploy, you'll see a bunch of sample scripts. I believe our Jenkins plugin source code is also hosted there. One of them is a load balancer example, right? So all we had to do to really get this to work was we went to AWS Labs, we copied the load balancer bind and unbind scripts, and we added them to our app spec. So relatively simple to get this functionality. The other thing we're going to introduce in Gamma is some validation testing. So we're getting ready to release a piece of code to production. We want to start adding some sanity checks to make sure that what we're actually deploying works as expected. So let's go back to GitHub, and we'll take a look at those changes. So here again is a commit in GitHub. This is the commit that we made to enable ELB redirection, as well as some sanity checks. You'll see it's an extra 5 lines of config in our app spec file. I should also note this is the reason why we really encourage people to revision control your app spec along with your application. It makes a nice history of how your deployment changes over time. We found this very helpful in our own environments. When a deployment fails, we can pull up the app spec and see if anything changed in it. And really quickly, we can tell if something weird is happening. So did we introduce a new script? That's probably a good candidate for failure. Did we change the order in which we deploy, et cetera, et cetera? Did we add new files? So in this case, we are adding 2 new load balancer scripts, one that runs before any event happens on the instance that unbinds it from the load balancer. We perform the deployment as usual. Then we have an ELB script which rebinds it at the end of validation. We're also adding a sanity check here, a validation script, to make sure that the application comes up and runs correctly. So relatively small amount of change to add this functionality. Let's go kick off a build in Jenkins and see if it works. So you'll see a new build start. We'll go to the console. So once the deployment starts, we should be able to go see it here in the CodeDeploy console. Hopefully. There we go. So we can drill down, take a look at the deployment. We should see here, some things have changed. We now are deploying to 3 instances. So in our test environment, we're having a slightly larger footprint. We're now deploying to an autoscaling group. Josh has created a custom deployment config called all but one. All but one is what it sounds like. We're going to deploy to all of the instances except for one. We'll always leave one available in case someone's trying to hit the website while we're deploying. So you can see we have 3 instances. We're deploying to 2 of them in parallel. Relatively straightforward. Oh, so you saw we have an instance that failed, which is an interesting event. Let's go to the events view and see if we can figure out what actually happened here. So again, now we're looking back at that set of events that happens on any instance. You can see we ran through all of the events except for the validate service event. So something happened when we tried to verify that the application came up. You'll notice we have a new link here, which is called view logs. Anytime we run a set of scripts as part of a deployment for a customer, if those scripts fail, we'll grab the last 2K of the log, and we'll make it available in the CodeDeploy console. This is a nice convenience method. It really lowers the iteration time to debug and test things as you're rolling them out. You don't have to figure out how to pull your logs from your instances or go find them or log into the instance and figure out what's going on. You'll get the last 2K of output kind of in the console. This one didn't actually produce any log data, but it did give us a message which tells us what happened. It looks like it was looking for a script to run, our health check script, and it couldn't find it. So that's not what we wanted to have happen. Let's go back to GitHub and see if we can diagnose what actually went wrong. So you'll see in the app spec file, we definitely reference that script, so we're trying to invoke it. CodeDeploy knows that we want to run this script, but it also knows that it didn't find it when we tried to invoke it. So it does the right thing, of course. It says, you told us to do this thing, we couldn't. Something went wrong. If we look at the files that we checked in, a quick look at them will reveal that we never checked in this validation script, so of course it never ran. We just hired an intern at Dogsuit Central, so I'm assuming that this was the intern's problem and not Josh's. The fix is relatively simple. We just check in our validation script. We should be able to just commit that and then kick off a new build, and hopefully this should remediate the problem. So we'll kick off a build and make sure it does. Got a new deployment. Let's go down and take a look at the instances. Excuse me. So new deployment started. Many of the things on this page is the same. We're still deploying to the test deployment group. 3 instances are being deployed to. We're still using the same deployment config. One thing you'll notice is that if you compared this deployment to the last deployment, you'll note that we're deploying to the same 2 instances that failed in the last deployment. That's not by accident. That's by intent. One of the things CodeDeploy does is it keeps track of the outcome of a deployment on every instance it deploys to. So it knows which instances failed a previous deployment and which succeeded. When we do subsequent deployments, we'll always prioritize failed instances first. This is so that we make sure that we, as much as possible, honor those health constraints that you tell us about. So if we were to pick a random set of instances and we picked the instance that we didn't deploy to, we would actually be taking out more capacity than we intended to. You would have 2 broken instances, and then we would be deploying to the 1 instance that was still working. That's not what we want. And so CodeDeploy will always pick the broken instances, deploy to them first, and then go complete the deployment on the rest of the fleet. So you can see these 2 deployments succeeded. 1 is in progress. Because we're using request routing, we should, in theory, be able to go to the website and refresh it and have everything work as expected. So Josh should be able to give us a couple refreshes just to prove it's not all fake. OK, so Gamma website seems to be up and running. It's hitting instances that are available with the new code. One thing you'll notice here is we've added a nice little debug banner at the top. So this tells us just some interesting information. It tells us the application that's being deployed. It tells us which deployment group we're looking at. So we're looking at the test deployment group. And it includes some ELB health state for the instances that are being deployed. So as you can see, from the load balancer's perspective, all 3 instances look to be OK and healthy. If we pop back over to CodeDeploy, we should, in theory, see a successful deployment. Good. So all the instances succeeded. You see the big green deployment succeeded checkbox. Let's go back and talk about what happens next. So production. So we've been working hard on the fitting algorithms. I think you'll agree this dog is looking pretty sharp. Things are starting to fall into place. VC funding is coming through. The buzz is happening. The media blitz, TechCrunch, everything. So it's time to launch this thing, right? What's going to happen different about our deployment process in production from the last 2 stages, from beta and test? One thing is that we're going to have a larger fleet footprint. So we'll triple the size of our test fleet. We'll deploy to 9 instances for illustrative purposes. I don't want us to use the all-at-once deployment config that we were using in test. That seems a little bit over-enthusiastic, overconfident. I also don't like the all-but-one. Again, it seems like we're exposing our customers to a lot of risk if we deploy to all the instances in parallel. So we're going to write a new custom deployment config. We'll do it a third at a time. So we'll over-provision our fleet by 33%, and we'll do deployments in batches of a third. So with 9 instances, we'll do the first 3, next 3, and then we'll finally finish up in the last third. So we'll introduce that. We're also going to take advantage of environment variables, which is something that CodeDeploy makes available to all the scripts that you run. So in that app spec file, any of the scripts that you invoke, we automatically make available to them a collection of environment variables that you can use to key off of and change the behavior. So we make available to you the deployment group that's being deployed, the deployment ID that we're currently deploying, the application name, et cetera, et cetera. So a collection of content that you can use to change the behavior. For us, we're going to production. We want to show the first 100 customers a sales banner, right? So first 100 dogs through the door are going to get a custom fitting for free, just to kind of drum up business. We also want to get rid of that debug bar that Josh introduced in test. It's great information for us, but it doesn't really make any sense to our customers, so we'll make sure that any of that debug messaging is cleaned up when we go to production. We can do that pretty easily by just checking to see which deployment group we're deploying to. If we see that it's the production deployment group, we won't show that content. So let's go and kick off a deployment and see if it works. Again, we'll go to Jenkins. We'll kick off a new build. This time, we're going to kick off a build to the production fleet. It's going to be a little bit bigger. There we go. So before we drill down to the instance view, I'll have Josh expand this little bar next to the deployment. As your fleets get bigger and bigger, the visualizations don't always scale, right? So if you're looking at 50 or 100 or 1,000 instances, looking at the instance state of every single instance is probably going to be a bit of an information overload. It's probably not going to be as valuable to you. So we introduced a couple different visualizations that we hope will scale for the different size fleets that you'll use. This one we call a rainbow bar. It's just a very simple visualization that shows you at a really high level what's happening across the fleet. So in this case, you can see 3 instances are in progress and 6 are pending. Since we set up a deployment config to do a third at a time, that logically makes sense to us. We can drill down for this one since we're only deploying to 9 instances. The visualization holds up fairly well. So again, you can see some information here. Production deployment group. We've created our own custom deployment config called a third at a time. And you can see that it's deploying. So you can see a couple instances have succeeded, and others are in progress. Essentially, as soon as an instance succeeds, assuming we still have capacity to deploy to, we'll pick another instance and deploy to it. So at any point in time, we should see 3 instances in progress and any number in succeeded, depending on where we are in the deployment overall. So I'm not going to sit here and make you guys watch this thing refresh and refresh. Because we're doing request routing, we should be able to go to prod and refresh it, and hopefully we'll hit a new instance. We did, great, that's good. So we got our sales banner up. That's what we wanted to see. We wanted to see, sales banner up and the debug information gone. Seems to have worked. We're routing our customers to instances that are not being deployed to. That's also what we want. If we go back, let's see if how the deployment is doing. Looks like we're on that last set of instances. Let's go look at the rainbow bar now, just so you can see what it looks like in a different state. So you can see now 6 instances succeeded, 3 in progress. We can give it one more refresh and see if we can get the green bars, but I won't make us wait here forever. Nope. So still 3 instances in progress. We can come back to it and verify that it worked. Let's just decompress real quick. So hopefully you've seen how you can use CodeDeploy in the various stages of your application development. We started off in tests. We took an application, bootstrapped it really quickly with CodeDeploy. It was relatively simple to do. We moved to tests. We had a larger footprint. We started introducing some validation. Then we went to production, and we made a larger fleet. We took advantage of environment variables to change the behavior. Hopefully you're getting a sense of how CodeDeploy can kind of grow and change as your deployment needs change. A couple things that we didn't get to today, just due to time constraints, that we want to add to this application. One is reactive deployment. So at Amazon and at our bespoke dog suit company, we're real big believers in continuous deployment. We want to be able to check in code and just have it get to production without any engineers messing with it. You can definitely set up CodeDeploy so that anytime code is checked in, you can kick off a deployment. We have a couple blog posts on this. If you're using GitHub, you can use post-commit hooks to trigger deployments as soon as you commit new changes. If you're using S3, you can take advantage of Lambda. So anytime you upload something to an S3 bucket, you can kick off a new deployment. Integrators, third-party integrators. As I said, we want CodeDeploy to be something that slots into your existing development process relatively easy. These are some of the things that are some of the teams that we've worked with to integrate with CodeDeploy. I showed you GitHub and I showed you Jenkins, but there's a ton more: Atlassian Bamboo, CircleCI, Chef, CodeShip, et cetera, et cetera. Several of the third-party teams are here at the talk. When we do questions at the end, they'll also be available if you want to ask them questions about using CodeDeploy with any of these products. Let's see. Multiple platforms. I did mention this at the beginning, but it bears repeating. CodeDeploy works on Windows. It works on Linux. We have installers for Red Hat, Ubuntu, Amazon Linux, Windows Server. If you can get Ruby 2.0 to run on your computer, it's relatively simple to get the agent bootstrapped and running. We also run in multiple availability zones. We also run on premises, so you can use CodeDeploy to deploy to your own servers as well as to EC2. Some new functionality that was introduced just last week. CloudFormation did an update, and they included CodeDeploy in this. For those not familiar, CloudFormation is a configuration-driven tool for setting up and configuring infrastructure. So with these two, I think they combine really well together. So you can use CloudFormation to provision your EC2 instances, to configure them the way you want, to configure your database, and then you can use CodeDeploy to perform the application deployments onto that new infrastructure. You can also use CloudFormation to set up the CodeDeploy infrastructure, so you can automatically create your applications and your deployment groups, et cetera, as part of a CloudFormation stack creation. This is really great when we talk about expanding our business to different regions. We can codify all of that in a piece of configuration in CloudFormation so that when we go to another region, it should be relatively simple to just launch the stack and go. This is also great if you're setting up, we're going to go through a round of hiring, of course, and so there'll be more developers. If we have a CloudFormation template that they can use to set up a dev stack sort of on demand, that's a really great way to kind of save time and effort. Thank you. I think that's all the content I have today. I appreciate you all coming out. Looks like we've got a little bit of time left. I can do questions. Please remember to fill out evaluation forms if If you would, tell us what you liked or didn't like or what you want to see next time. Thanks for coming out.